Okay, so this is a little bit of theory, okay. If we have two tanks of water, okay, tank A and tank B, well, if we hook some water level sensors up to them, okay, we'll be able to tell when the water drops to a certain point, okay, which will tell us that we need to refill our tanks, okay. So when these water level sensors detect water in the tank, they give off a high, okay, and we can see that two highs means that the output from this NAND gate should be low, and that won't turn on this LED, okay. So if one or more of the water level drops below our water level sensor, it will give off a low, okay. So that will ensure that we get a high here at the output of our NAND gate, and that will turn our LED on, okay. So that follows this truth table here of our NAND gate, okay. So this LED could be connected to a control panel, where as soon as we see it come on, we know that the water level in either tank A or tank B, or in tank A and tank B, could have fallen below our water level sensor, which means that we need to go out and refill our tanks, okay. And that's it, okay. In this circuit, we're looking at some applications that we can use the quad 2 input NAND gate in, okay. So pin 1 is connected to 5 volts, okay, which is therefore high, okay. Now pin 2, we've connected here across this voltage divider circuit, okay, where we're having a light dependent resistor in series with an ordinary resistor, okay. So we've set it up where when I put my finger over the light dependent resistor, the voltage will drop, okay. Because the resistance is increasing, okay. So we want to get around 0.8 volts or less here, okay, because if you look at the spec sheet, it will tell you that to ensure that there's a low on pin 2, which we want, the voltage should be anywhere from 0 volts up to 0.8 volts, okay. So we do actually get 0.8 volts here, okay. So what happens is that means that pin 2 is low, okay. So that will mean that pin 3, which is our output, will go high, okay, and that will turn on this this LED here, okay. So this is pretty much like a dark detector circuit, okay. So we'll see now will it work, and you can see that it does, okay. So in this next circuit, we've removed the LED, and now what I want to do is I want to turn on this motor with this fan on top of it, okay. So the same principle applies as before. If I put my finger over the LDR, this will ensure that we get around 0.8 volts at the output, which is enough to ensure that pin 2 goes low, okay. And then pin 3 then will go high, and that will turn on this transistor, which is used to drive this motor here, okay. Now I've added a second voltage source in here, okay, and that's used in conjunction with this motor here to ensure that it has enough power to operate properly, okay. So all our grounds are connected together, which is important. Okay, so up on this rail we have 9 volts, and then on this rail we have 5 volts, okay. So let's see, will it work? And it does, okay. And that's pretty much all you need to know.